Ruth toka hapa.
Hello, so I'm Kevin, and today I'll be taking you through the determinacy of truss. So So the specific learning objectives by the end of the lesson, the learner should be able to differentiate between statically determinate being and statically determinate statically indeterminate. So, okay, so when you say determinacy of a truss, we mean if the truss can be solved by the three equations of equilibrium. So, determinacy of a truss. So, determinacy is either the beam is determinate or indeterminate. So, a determinate truss is a truss which can be solved using the three equations of equilibrium. So, what are the three equations of equilibrium? The three equations of equilibrium are: one, summation of vertical forces is equals to 0. 2, summation of horizontal forces is equals to 0. 3, summation of moments at a point, let's say A, is equals to 0. So these are determined to be if it can be solved by the three equations of equilibrium. So a statically indeterminate beam determines a truss is a truss which cannot be solved using the three equations of equilibrium. So we've already known what a determinate truss is and indeterminate truss is. So next, I'll be taking you through the formula for to determine if the truss is determinate or indeterminate. So the formula for determining is M. This member plus joint should give you 2R. So M is the member, J is joint, then R is the reaction or forces acting. We've already we've already written the formula, which was member plus the joint is equals to two reactions, 2 multiplied by the forces which act on the given truss. So, for you to understand, I need to draw a truss. Let me take a ruler so that I can explain. So, in our truss, let's say, so our truss looks like this. So this is the truss. Then so in our given truss, let's say these are fixed. Here we give it a roller supports. So here we give it a pin supports. So let's start with the members. How many members do we have? So members members are this. Members is something like this. Going from point A to element A, B, C, D, E. So our first member is from A to B is 1, B to C 2, B to D 3, D to C 4, D to E 5, E to C 6, A to D 7. So as you see, we have 7 members. So joints. So the joints are this 1, 2, 3, 4, 5. So the joint is the point in which members meet. So we have 5 joints. So for reaction, in our case, we have fixed. So in fixed, we have 3 forces acting on it. So we have moment, we have vertical, and we have horizontal. So in our roller supports, we only have one. Roller supports always have one force, which is a vertical force. So in pinned supports, we normally have two forces, which is vertical force and horizontal force. So as we have labeled, we can now count the reactions. So from on the farthest end A, we have 3. So at point D, we have 1, and at point E, we have 2. So 3 plus 1 plus 2 is 6. So from our formula, we can determine if this truss is a determinate or indeterminate using our formula. So the formula was member added by number of joints. Number of members added by number of joints should give us 2 into the number of reactions. So in our case, we have 7 members plus 5 joints is equal to 2, 6. So this 12 is equal to 12. So this truss of ours is a statically determinate truss. So this will determine this as we are finding 12 is equal to 12. So these are determinate truss. So what if so for our next so in the next thing is we want to determine this determinancy of this example if it will be a fixed support. So this means will not be having one reaction. So we will not be having moments. So we used it as a fixed. So we'll be having vertical and horizontal forces only. So member will still remain the same. This is 7. Joint still remain the same. 5. So where we have altered is the number of reactions. So here's 2, 1, 2. 2 plus 2 plus 1 is 5. So from our formula, remember, number of members added by the number of joints should give you 2 to the number of reactions. So for this instance, we have 7 plus 5, which gives you 10. So this structure, this truss structure is not determinate. So we've come to the end of the lesson. I think this is the whole stuff, the whole objective was achieved, and you've understand. You can now determine if a truss is determinate or indeterminate. So for let me give you an example, and let me give you an assignment. So for assignment, I want you to use this roller support. You make it to be fixed. So make it to be fixed. Then you determine the determinacy of this truss. So for I think for further reading, you go to Engineers Insights channel. You go look for the determinant. How they find the determinacy of the trusses. They have a good example. So thank you. Let's meet next in our next video.